So now we're on page 146, a few pages ahead, looking at a special part of the quadratic formula called the discriminant. So we all know the quadratic formula, we've all used it, and in the last part we were identifying the number of solutions. So to answer some of those questions of two solutions, complex, real, rational, irrational, we actually don't need to plug the whole thing into the quadratic formula. We can look at a special part of it, which is the discriminant. It's basically everything underneath the square root. So whatever you see underneath the square root, that is a discriminant. We have that over here in our math term as well. So the discriminant helps us identify some of the parts of the solution. It's what's called the nature of the solution or solutions. So that nature is the whole real, complex, imaginary, or not imaginary, or basically rational, irrational. Okay, so it helps us identify that without having to plug it all into the quadratic formula like we did just a second ago. So we still need a quadratic, so yeah, it still has to be in that ax squared plus bx plus c. You'll still need to identify a, b, and c, but instead of plugging into the quadratic formula, we now plug it in to the discriminant, b squared minus 4ac. That's what we're going to use all today, b squared minus 4ac. Now, depending on what you get, that tells us different types of natures. So if your answer is greater than 0 and a perfect square, then it's two real and rational. Two real, two rational solutions. Okay, if it is greater than 0, but not a perfect square, then it's still two real, but now the other part is irrational, meaning there's a square root. Which makes sense, because if it's not a perfect square, you can't take the square root of it. Okay, if it's equal to 0, so equal to 0 means there's one real root. And then the last one, if it is less than 0, meaning you have a negative underneath the square root, there's going to be an I. So because there's an I, we get two complex solutions. And these are special solutions. We call them complex conjugates. We've talked about complex conjugates before, where you have the opposite of the imaginary term. There's two of them. So we saw these in the last example. Like if we go back to the problems we just looked at, notice if we just focus on what was underneath the square root, like right here, we got square root of 121. That is a perfect square, so 11. So that means we had two rational solutions using our table. And notice we have two rational real solutions because it was a perfect square. In that second example we did, it was not a perfect square. We just left it as square root of 57. So the nature should be two real and irrational. So notice we got two real irrational. This last one, or this one, square root of 0, so we got 0 for the discriminant. When you get 0, notice there's only one solution, because that whole plus or minus 0 doesn't do anything. So we get one real rational solution. So one real rational. Again, all this is coming from our table. Last one, when you look at this discriminant value, you get a negative. It's a negative, it's a negative 64. So that negative 64 means that it's going to have an I. So we say it's too complex. Again, we don't worry about rational, irrational. So that's how we work this table. Like this table told us the same thing that we just found using the quadratic formula. But instead of using quadratic formula, we can use the discriminant to get the answer quicker. So let's look at an example or a couple examples using the discriminant. So first thing we have to do in every problem is identify A, B, and C. So right here, let's identify A, B, and C. So A equals 4, B is 5, C is negative 6. So we could plug it into the quadratic formula and actually find the solutions. But let's try the shortcut method. Let's use B squared minus 4AC. Let's just identify the nature. So B squared would be 5 squared minus 4 times negative 6. Okay, so we have 5 squared is 25. Negative 4 times positive 4 is 16. Negative 16 times another negative 6 is positive 96. So anyway, we get 112. Okay, is 121, Is 121 a perfect square? Meaning, if we take the square root of 121, do we get a whole number? Yes, we do. We can take the square root and we get 11. That is a perfect square. So notice we're going to use this first box. We got something greater than 0 that is a perfect square. So our answer is 2 real, rational solutions. That's how we identify nature quickly from the discriminant. So you don't have to use the rest of the quadratic formula. So let's look at this next example. Let's first identify A, B, and C for this problem. What's A, B, and C? So A is 4, B is 5, C is -2. So now let's plug it into the discriminant. So that's B squared minus 4AC. So we do 5 squared minus 4 times -2. So we can plug that in our calculator. Okay, so we have 5 squared, which is 25. And it would be minus 4 times 4 is 16, times the -2 would be -32. So negative is positive 32. And then when we add those together, we get 57. So again, you could have just typed all of this in. You don't have to do any of that mental math right here. We got 57. So notice 57. Is 57 a perfect square? Can we take the square root of it and get a whole number? No, we can't. It is not a perfect square. So I'm going to put PF for perfect square, not a perfect square. So we look back up here at our table. We did get a positive discriminant. That is not a perfect square. So we look over here. That means we have 2 irrational solutions. That's all I write, 2 irrational solutions. That is our final answer. Put IRR for short, 2 irrational. And they're real solutions. So 2 irrational real. So all we're doing when we're talking about nature, this is all about nature of solutions, is you're characterizing them. How many there are and what's their type. Again, that's real or complex, rational, irrational. So let's look at a couple more examples and then you'll practice on your own. So first thing we need to do is identify A, B, and C. You may notice these are starting to repeat from earlier. So A, 4, 4, and 1. So instead of plugging into the quadratic formula, we're using B squared minus 4AC. So it's going to be 4 squared minus 4 times 1. So what do we get when we do 4 squared minus 4 times 1? Notice we get 0. So this is 16 minus 16. We get a discriminant of 0. Let's go back up here to our chart. So when you get discriminant 0, it says it's one real rational solution, or it's also called a double root. Real rational solution. It's a double root. So that's all you put. One real rational solution. That's what you were looking for the answer. Okay, let's do one more. B squared minus 4AC. So first, let's identify A, B, and C. So 4, 4, and 5. Now, plug it into the discriminant, and I want to know what you get. So when we plug this in, when we do 4 squared minus 4 times 5, you type in your calculator, do the mental math, whatever, you get -64. So our discriminant is negative. So going back up to our table, what does it mean when they're negative? Okay, when the discriminant, or B squared minus 4AC, when it's negative, there are 2 complex conjugate solutions. So that's what you write. That's your answer. 2 complex conjugate solutions.